So last week we spent some time on finding slope from a graph. So as long as we could find two lattice points, so that's 2 points on our line that match up with whole numbers. Those are the ones that go right through the cross where my line goes through the cross of the grid lines. So it's a whole number here. If I had a point here, that would not be on a whole number. So it would be really hard for me to do my slope triangle. So that was our focus last week, is finding slopes from lines based on drawing the slope triangle. Now we're going to extend that a little bit, and what if I know 2 points on my line? I don't have a graph, I can't make a slope triangle, but I know 2 points that are on my line. I can still find my slope, even though I don't see the line. So we're just going to do a quick review so I can take you from the graph to figuring out the slope, knowing 2 points that are on my line from the graph. So just as a review, I have a line with several lattice points here, and if I make a slope triangle here between these 2 points, I can see, okay, I'm going up to the right. So as I travel from left to right, I'm going up and right. So that's a positive 2/3, right? So I could say that my slope is a positive 2/3. Now, if I pick two further points, points that are further away, and I pick these 2 points, this is a distance of 4 and this is a distance of 6. So some other student may say, well, I've got a slope of positive 4/6. Okay, so you would both be correct. So no matter which 2 points you put or you choose on your line to do your slope triangle, you would get maybe different looking slopes, different looking ratios, but the ratios are equivalent, because if I take my 4/6 and I break that down from a common factor, 4 and 6 have a common factor of 2. So I'm going to rewrite 4 as 2 times 2. And I'm going to rewrite 6 as 2 times 3. And then that common factor makes a big 1. So here I'm showing that 2/3 and 4/6 are equivalent. So that's why if you might have slope ratios that look different from another student, but that doesn't mean that they're wrong or that they're different in value. So as long as you have an equivalent ratio, that works. Now I know when sometimes you put in answers in IXL or in Pearson, they like it to be in simplest form. They like your slope ratio to either be, if you can simplify it to a whole number or simplify it to a smaller fraction, that's what they prefer. And if you ever need to figure that out and you're not good at reducing fractions, then just open a Google tab and type in, can I simplify 2/3 or can I simplify 4/6? And that should help you try to find a simpler version. Okay, so that's where we were last week. So now I'm going to erase all of this. And now what we're going to do is we are going to take actual points, actually locations on the grid, on the line, and so actual data points. So ordered pairs, an XY pair. Remember, ordered pairs always come in the order the X direction first and the Y direction second when we actually are looking at a location on a grid. It's kind of like the GPS. So for this first point here, if I'm starting at 0, 0, that's 3 units right and 5 units up. So that is going to be at a position of 3, 5. Okay. If I look at the next point up here, X first, so the horizontal direction first, I came over 6 grid lines to the right, and then I went 7 grid lines up. So that location is going to be 5, 7. And then if I wanted to extend one more point, I could. And it's in relation to the center of my graph at 0, 0. I came 9 units to the right, and then I went up 9 units. So this would be a location of 9, 9 on the coordinate plane. So with those points, if I just knew points without the actual picture of the graph, I could find my slope. So let's take a look at that. I put our values in a grid, or not in a grid, I'm sorry, in a table. So I took the 3 points that we got from the table, and I'm sorry, and from the graph. I made a little boo-boo, and some of you might have caught that, and I just caught it now. The second point, it's not 5, 7. I actually came over 6 grid lines and went up 7. So that point is actually 6, 7. So some of you may have caught that. And if you did, congratulations. I'm just glad I caught it. Okay. So I have 3, 5, 6, 7, and 9, 9. Okay. So I'm going to put those points into a table. And I have 3, 5, 6, 7, and 9, 9. That's how I caught my mistake, because I already had this table set up. Now, before last week, we've been talking about y to x ratios to check for proportional relationships. We've been talking about rate of change, and that idea of rate of change and slope go hand in hand. So you can actually find your slope based on that rate of change. So if you went from this output 5 to 7, that was a change of 2, right? And then if you went from 3 to 6, that was a change of addition of 3. So you can see that 2 to 3. That's my delta y, and this is my delta x. And that notation should be familiar to you based on what we talked about in class. So slope is delta y divided by delta x. In this case, it would be the change in y divided by the change in x. That's 2/3. Okay, now say we were that student who chose to pick the 2 points, maybe 2 points that were farther away. Maybe they didn't choose 2 points that were closer together. Say they jumped from 3, 5 to the point 9, 9. Well, this would have been an increase of 4. And then 3 to 9 would have been an increase in 6. And so my delta y would have been 4. My delta x would have been 6. But as we saw before, when I was finding the slope on the actual graph, 4, 6 simplifies to 2/3. So again, we have an equivalent ratio. So that's why it doesn't really matter which 2 points you pick on your line. Because your line is straight, the slope ratios that you get from any 2 points on the line are going to be equivalent. Okay, so that's one way you could actually find your slope from a table. You could put your data points in a table and just find your distance. Now, there's actually also a slope formula, and it's more formalized in a formula. I would say that putting your points in a table and then finding the distance is a little more informal. But when we talk about distance between points, let's just think about a number line. I like to think about a vertical number line. I could fit it a little bit more easily under my camera, but I'm not even going to show you anything right now. I'm just going to ask you, what is the distance between 2 and 9 on the number line? Okay, you don't have to look at a number line. You don't need to count. Some of you may be able to figure out, oh, I already know my distance between 2 and 9. And some of you may say, oh, it's 7. And I'm going to ask you, how did you come up with 7 so quickly? What did you do with your 9 and your 2 that got to that distance of 7 so quickly? And many of you would say, well, I subtracted them. So subtraction is the operation that helps us find distance. So between 2 points. So if I go back and I demonstrate that here, we were at 2 on the number line, and I wanted to go to 9. I could count it along my number line. For some of you, that might be easier, and that's quite all right. But for others of you, you could just say, oh, I'll take my 9. That's where I want to go. 2 is where I want to start. If I just subtract that, I should have 7 units in between there. Well, let's check it out. Here's 1, 2, 3, 4, 5, 6, 7. So the distance between 2 and 9 is 7. So I want you to keep in mind that in order to get distance between 2 points on a number line, the operation we would use is subtraction. And the axes, the coordinate plane, is just made up of two number lines. Here, where'd my graph go? Over here. So it's made up of a horizontal number line, and it's made up of a vertical number line. So really what I'm doing when I'm finding slope is finding distance between the points. I'm finding the distance in the y direction, and I'm finding the distance in the x direction. Okay, so subtraction is the operation that's going to help me. So let's talk about this a little bit further. Just as a quick snapshot review, slope is what tells you the steepness of a line. How steep is my line? The larger the value of your slope ratio, the steeper your line. Your slope also has direction. It can go up to the right, positive slope, it can go down to the right, negative slope, and as you saw last week, I could have a flat horizontal line, which is zero slope, and I could have a vertical line up and down, straight up and down, that is an undefined slope. So slope is really telling us the steepness, and the slope is determined from a ratio called the rate of change. So it's my change in y, or my delta y, divided my change in x, delta x. Informally, we can refer to that as rise over run. So when I was doing that little slope triangle, that vertical distance was my rise, and the horizontal distance along my triangle was my run. So any one of these things that I'm talking about here, you can use that notation and you can speak in that language, and you're talking about the same thing. Slope ratio, slope, change in y, change in x, rate of change, delta y divided by delta x, rise over run. All of those ideas are really talking about slope. How steep is my line? So we talked about getting the slope from the graph. We talked about putting a couple of points from your graph right in a table and then finding the distance between those points. So before I said delta y and delta x, well, this is my rise. Okay, if you want to talk about it informally, and this plus 3 here, that would be my run. Okay, delta y, delta x. So you could call it many different things, but we're really all talking about the same thing. Now, if I take a look at this formula, let's take a look at this formula. This is the formula that you might see in a textbook. You might have seen it online. You might have seen it in a video. And you'll see this thing that says y2 minus y1 divided by x2 minus x1. And this is a formal way of just saying, help me with my rise and help me with my run. And the little 2 and the little 1s here are not exponents. They're not being raised to a power. They're below the y. They're called subscripts. They're below the variable. It's just identifying the two separate points. So that we want to say that, well, this y value here, the y2, is from a different point than the y1, okay? And so we're just making that differentiation. So I can say that the first point, well, this is my x1, y1, and I could say that this is my x2, y2. So I can identify point 1 and point 2 so that when I use it in my little slope formula, I don't get mixed up. So, and we also mentioned that the subtraction right here, helps us get distance between points. So when I subtract the y values, I'm getting the rise or the delta y. And when I subtract x values, I'm getting the run or the delta x. So when I set it up to do my calculation, I kind of like it to be neat and give me a way so that it won't be confusing. So I just put little parentheses, they're little placeholders, so I know, okay, I'm going to substitute a value in each one of those 4 places. So the first position here in the upper left would be my y2. Well, my y2 is 7, and my y1 isn't from the same point. I don't have a y-y pair here, I have an x-y pair. So I pulled the y from the second point, 7, so now the y1 is going to be from the first point. The y position in the first point, that's going to be 5. Okay, so that's going to get me my vertical distance on my slope triangle. Now for my run, or my delta x, so I see this x2, all right, so I'm going to go back to that second point where my x2 is and grab the x value. So that's 6. So you can see this 6, 7, they are right vertically connected, right? But it's the y values that go on the numerator. The x values go on the denominator, and that's a common mistake. Okay, so make sure y's are in the numerator, x's are in the denominator. So 6 is my x2. Now I have to go back to my first point, my point 1, and pick up my x value of 3. Okay, 7 minus 5 is 2. 6 minus 3 is 3. And voila, we have our slope. And that's the same slope we got from the graph. We just got it from 2 points from that graph. Now what I want to show you is, some of you might say, well, does it matter which one you call y1 and y2? And it really doesn't. So I'm going to run through this one more time. And I'm going to call this x2 and y2. And I'm going to call this x1 and y1. Okay? So I just renamed the points to show you that it's not going to matter one way or the other where I start. What matters is that I'm consistent. So whatever y I start with, its x partner needs to go right below it. So if the 5 is my y2, okay, and then the 7 is my y1, okay, so my y's are in the numerator, then whatever x is paired with this 5 has to go right below it. So since 5 is in this point over here on the left side, I can't pull the 6. Okay, I have to pull the x value that goes with that 5, so I have to put the 3 down below it. That's my x2, and then 6 goes down below the 7. Okay, now 5 deduct 7, okay, I'm taking away more than I have, that's going to be negative 2. 3 minus 6, I'm taking away more than I start with, that's going to be a negative 3. But a negative divided by a negative is a positive. So again, I'm going to have a positive 2/3 slope. So it didn't matter which point you started with and which one you used first and which one you used second. Okay, so I just want to point that out. Okay, so we're going to practice one on your own here. And just need a second here to get situated. Okay, so I'm going to put 2 points in a table, all right? So I'm going to start with the table, and then we'll go to the more formal slope formula. So I have the points 1, 5, and 3, negative 2, okay? So I have one spot on my paper where I'm going to put the 1, 5, and the 3, negative 2 in a table, and then I'm going to find distance. And then here, I'm going to find distance with my subtraction. So let's zoom in on my table. And to travel from 5 to negative 2, I really have to think about it. Now, I think a lot of kids are going to get tripped up and say they're going to add 3 or take away 3 or something like that. They're going to take 5 minus 2 and say the distance is 3. But the distance between 5 and negative 2 is not 3. I want you to think about, where is 5 on the number line? It's above 0. So where is 2 on the number line? It's below 0. So I'm going to have a pretty fair amount of jumps to get from negative 5 or from positive 5 to negative 2. And if I look back on here, here's my 0, right? Here's 0 right here. 5 is 5 above, but negative 2 is 2 below. And that's not a distance of 3. I'm not adding 5 with negative 2. I am actually trying to travel from 5 on the number line to negative 2. So here we go. 2, 3, 4, 5, 6, 7. So that's actually a decrease of 7 to get from 5 to negative 2. So if you need to put together a little number line for yourself so that you can check yourself on this distance, if you put your points in a table, then please do that. So to get from 1 to 3, I think that's easy. That's an increase of 2. So my delta y divided by delta x, or my slope ratio, is negative 7 divided by 2. Negative divided by a positive is a negative. So I would just consider my slope negative. That means my line's going to go down to the right. Okay, so easy as that. Now, if I want to more formally use the slope formula, like I said, it doesn't matter where I start. Usually what I do, I just pick the first point and start there. But remember, the y's have to go in the numerator, right? So if you want to just remind yourself that it's x, y, x, y. I put the 5 first, and then I'm going to put the -2 second. And then I'm going to put the 1 down below the 5, and then I'm going to put the 3 down below the -2. Okay, taking away negatives. Remember, this subtraction is very important in your formula. If you put an addition sign there, that's not going to get you distance between points. So your slope is going to be incorrect. Remember that operation in your slope formula needs to be subtraction to find distance. But if I'm taking away negatives, in class we said that taking away negatives is really increasing value. So that's going to end up, being 5 plus 2, right? And then down below, I don't have taking away negatives here, it's just 1 minus 3. So that can just be written 1 minus 3. So 5 plus 2 is 7. 1 take away 3, I'm taking away more than I have. Taking away 2 more than I have, that's a -2. Positive divided by a negative is a negative. So my slope is -7/2. Now let me zoom out a second. So it doesn't matter whether you use the slope formula or you used a table to put your points in, you should end up getting to -7/2. Okay, so now I'm going to have you do one to practice.